solving systems of linear equations by elimination. So this is the final method that we're going to learn to solving systems, okay? And most people end up liking this one the best. Totally up to you which one you want to use. Obviously, I'm going to test you on all three, but once I test you on all three, you choose where you want to go from there, okay? So I wrote out all the steps for you. So what you want to do first is make sure that your variables are lined up. Okay, so we want x over x, we want y over y, and we want our numbers over each other. Okay? So how this is written, this is called standard form, when you have your x's and your y's on one side of the equal sign and your numbers on the other. Okay, so again, just make sure the same variables are on top of each other. So the second step is to make one variable match the coefficient of the other but opposite signs. So in example 1, I want you to notice that the x both have a 2 as their coefficient, right? The number in front, but one's positive, one's negative. That's what I'm looking for. The same two numbers, but opposite signs. So again, one positive, one negative. Okay, once I have that, I'm going to add the two equations together. Okay? So I'm just going to be combining my like terms. The reason why this works is because if I add 2x plus negative 2x, guess what happens? These cancel out. So my variable is eliminating, okay? I'm literally eliminating one of the variables from my equation so that I have a one variable equation to solve. Okay, so now I'm going to add the negative y and the 4y. That becomes positive 3y. And then you're going to add the negative 5 and the 14, which becomes 9. Now look at this super easy equation I have to solve. Okay, I'm going to divide both sides by 3, and I now know that y is equal to positive 3. And now you're going to use the same method that we did in substitution to find your second variable. So you literally just plug in y to either, let me do it in a different color, to either this equation or this equation. It doesn't matter which. I'm just going to plug it into this top equation. Okay, again, it doesn't matter which one, you'll get the same answer. So negative 2x minus, well, instead of putting y, I'm going to put 3 because I know y is equal to 3, equals negative 5. And now I'm going to solve this equation right here. So I'm going to add 3 to both sides. So I get negative 2x equals negative 2. Divide both sides by negative 2. And I know that x is equal to 1. Okay, and remember, a system deals with graphs, so I'm going to write my answer as an ordered pair. So I get 1, 3 as my final answer. Okay, so in number 2, same thing. My variables are lined up. I already see that my x's have the same coefficient. One's positive, one's negative, so I'm already set to add my two equations together. Okay, so I know my x's are going to eliminate, and I have 10y plus negative 9y, which is just positive y, equals 24 plus negative 16, or 24 minus 16. Okay, and that's positive 8. Look at that, I already have one of my answers. Super easy. Okay, and then you're just going to plug in y into any equation. I'm just going to do the bottom one since I did the top one and the other one. So instead of negative 8x plus 10y, I'm going to put negative 8x plus 10 times 8, right, because I know y is equal to 8, equals 24, and I'm going to solve for x. So plus 80 equals 24. So negative 8x equals negative 56, right? Divide by negative 8. So x is equal to positive 7. Okay, so now I have my two answers. I know x is equal to 7, y is equal to 8. There's my ordered pair, and we're good. Okay, number 3. So I'm good with my variables lining up. I have x's over x's, y's over y's, and my numbers over each other. So I'm going to look, and I see that my y's have the same coefficient, but they're not opposites. So I could actually change one of these equations so that they will be opposite of each other. Okay, so what I'm going to do is I'm going to multiply every single term by negative 1. Okay, so this is going to become negative 2x minus 3y equals 11. So I could change these variables how I want by multiplying it by something, but if you multiply by something, you got to multiply everything so that it stays as a balanced equation. Okay, so once I change this equation right here, I'm going to cross it out, and I'm not going to use it. Okay, I am now going to use these two equations together because now I have my y's matching but having opposite coefficients. So again, once that happens, I'm going to add the two together. So this becomes 6x, now my y's will eliminate, equals 19 plus 11, and that's 30. And I'm going to solve for x. So x is equal to 5. Now you could plug in x into this equation I crossed out, into this equation right here, or into the equation that I just created. Okay, I'm going to do it in the one I just created. Let me do it in a different color. So negative 2 instead of x, I'm going to put positive 5 minus 3y equals 11, and I'm going to solve. So negative 10, add 10 to both sides. So I get negative 3y equals 21, divide by negative 3, so y equals negative 7. So as an ordered pair, my final answer is 5, negative 7. Okay, number 4. So everything's lined up. I'm trying to see, do I have any numbers that match with my variables? And in this case, I don't. Okay, so again, you could multiply one equation or two equations so that you have a variable that has the same two numbers in front but opposite signs. Now, you could either choose the y to eliminate or you could choose the x. Well, I think the x is going to be easier to eliminate. So think about it. What would be the number that needs to be in front of x that when I add these two equations together, the x's eliminate? Well, I know this is negative 10, so I need the opposite of that, so that'd be positive 10. So that's what I'm going to multiply everything by. So I'm going to multiply the x by positive 10, the 2y by positive 10, and the negative 4 by positive 10. So my new equation is going to become 10x minus 20y equals negative 40. Now I'm going to cross that out, and I'm going to rewrite that top equation underneath so it's easier to add the two together. So I'm going to rewrite the negative 10x plus 10y equals 10. Now notice my x's now match but with opposite coefficients. So I'm able to add these together. So now my x's are going to eliminate. So I'm left with negative 10y equals negative 30. Solve for y. So y equals positive 3. Okay, you could actually plug in the y to this equation from the top, the new one that you created, or this one right here. Now, if I wanted to use this one right here, you would still get the same answer for x. So x minus 2, and I'm going to put 3 instead of y, equals negative 4. X minus 6 equals negative 4. Add 6 to both sides, so x equals 2. Okay, so my final answer would be 2, 3. So I know I crossed this equation out. It's just so that you don't use it when you're adding these two together, okay? But once you get your first variable, you could definitely use it to plug in that answer and find your second variable answer, okay? It doesn't matter. Okay, so number 5. I'm looking at this and it doesn't look as simple as the other one, right? I can't just look at my x's and think, oh, I can multiply 4 by something and it'll be the opposite of negative 7. I can't multiply 3 by something and have it be the opposite of negative 5, right? And vice versa. So that means I have to create opposite coefficients by changing both of these equations. Now, it doesn't matter which one you choose. You could choose x or y. I'm going to choose y because our x's have been eliminating, so why not? Okay, so think of a number where you could make 3 and 5 match at by multiplying both of them by something, right? Hopefully, you're thinking 15. So how could I change this so that this would become 15? Well, that's by multiplying by 5. Well, if I multiply this 3y by 5, everything in the equation has to get multiplied by 5. So my new equation is going to be 20x plus 15y equals 40. Okay, and I have to do the same thought process in the second equation. So remember, I'm trying to make the y's eliminate, so they need to be the same number but opposite signs. So luckily they're already opposite signs. Okay, and how could I change this so that it becomes negative 15? Well, I need to multiply by 3. If you multiply one piece by 3, you have to multiply everything by 3. So I get negative 21x minus 15y equals negative 45. Okay, once you change these, cross these out so you don't mistakenly use them going forward when you're adding these two together. Okay, so now my y's match, but they are opposite signs, so I'm going to go ahead and add the two equations together. So 20x minus 21x, that's negative 1x. My y's go away, and I have negative 5. Divide both sides by negative 1, so x equals positive 5. Now, I could use x equals 5 in this equation, or the ones I crossed out. I'm probably going to use one of the ones that I crossed out because it's smaller numbers to deal with. So I'm actually going to plug in the x to this top one that I crossed out. So I'm going to have 4 times 5, what else did I have? Plus 3y equals 8. So 20 plus 3y equals 8. Subtract both sides by 20. So 3y equals negative 12. Divide by 3, so y equals negative 4. Okay, so my final answer would be 5 comma negative 4. Okay, number 6. So remember, your first step is always to make sure your variables are lined up. Well, in this case, they're not. Usually we like to put it in standard form, so x's and y's on one side and your numbers on the other. So you have to actually rearrange these so that your variables are lined up. Okay, so I'm going to make this 3x minus 18y equals 24. Okay, so all I did was subtract the 18y to the other side. So we have that. In this one down here, I'm going to add the 11y. I'm going to add the 11 to this side. I'm going to bring over the 9y. So my new equation is going to be x minus 9y equals positive 11. Okay, so I'm going to cross these out now. And these are the two equations that I'm looking at. So let me separate these. Okay, so let's look at what variable would be easiest to eliminate. I'm looking at the x's. This x doesn't have a coefficient, so I think it's going to be pretty easy to change it so that it'll eliminate with the other x. Well, it needs to be opposite of this, so that means I need to multiply by negative 3. But make sure you're doing it to everything, so this becomes negative 3x plus 27y equals negative 33. Okay, and then I'm going to cross that out. I'm going to rewrite this equation below so I don't make any mistakes. So this is 3x minus 18y equals 24. Okay, now that these are opposites, I know my x's are going to eliminate. So add these together. Okay, and then I get 9y equals negative 9, so y equals negative 1. So again, it doesn't matter where you plug in y. It could literally be this very first equation right here that I started with, which I'm actually going to do that. Why not, right? So negative 11 plus x equals 9 times negative 1. So negative 11 plus x equals negative 9. Add 11. So x is equal to positive 2. Now you could have plugged in y here, 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 or here. You literally have so many options because these are all technically the same equations. They just look different. Okay, so again, we write our answer as an ordered pair. So 2 comma negative 1, would be my final answer. So number 7, luckily my variables are already lined up, and I'm looking at which variable I could eliminate. I could make -4 match -12, and I can make 9 match 27. So it really doesn't matter which one you choose. I'm just going to choose the x. Okay, remember, the numbers need to be the same, but they need to be opposite signs. So the opposite of -12 would be positive 12. So ask yourself, what times -4 would give me positive 12? Well, that's -3. So I'm going to multiply by -3, but remember, if you multiply one thing, you have to multiply all 3 of them. So that becomes positive 12x minus 27y equals -54. Okay, and then I'm going to cross that out because this is the new equation I'm going to use. Okay, and then I'm going to rewrite the top equation underneath. So -12x plus 27y equals positive 10. Okay, and now I'm going to add them together. So my x's eliminate, and actually now my y's are going to eliminate. So I'm left with nothing. Okay, think of what number you use that represents nothing. Well, that's 0 equals -44. Well, what do you think that means? Right, remember, when your variables eliminate and both the sides don't equal the same thing, what do we write? That's going to be no solution. Okay, and then we're done. That's it. No variables to solve for. They're gone. 0 can't equal -44, so I don't have a solution in this situation. Okay, number 8. Again, luckily these are all lined up. Okay, so again, you could use the x's or you could use the y's. I can't multiply 3 by anything to make it opposite of 5, and I can't multiply 6 by anything to make it opposite of 10. So this is one of those cases where you're going to have to multiply both of them. Again, I'm just going to use the x's, so I know that 3 and 5 can match at 15. So I'm going to multiply this one by 5. So that's going to become 15x minus 30y equals 15. Now if I multiply this next one, I need it to be opposite signs. So I don't want this to become 15, I want this to become -15. So that means I'm going to multiply by -3. So that becomes -15x plus 30y equals -15. Hopefully you kind of are catching on to where this is going, right? If I add these together, the x's go away, the y's go away. That's 0 equals, well, 15 plus -15 is also 0. Well, look at that, right? Variables eliminated, both sides equal the same thing. Usually we would write all real numbers, but remember, we're talking about lines, right? We're talking about a graph, so when we have systems, we don't put all real numbers. All we say is infinitely many. These are the same 2 lines, so they're intersecting on the same line forever and ever and ever. Okay, now I gave you 2 U-tries, so I want you to pause, try the U-tries, and then come back and play and see if you get the same answer as me. Okay, so number 9, the variables are not lined up, so I'm going to rearrange this one in the dark purple. So I'm going to subtract -30y from both sides. So I'm going to get 24x minus 30y equals 30. And then I'm just going to switch the x and the y so that the x's and y's are going to line up in that bottom equation. So I'm going to put -6x plus 8y equals -12. Okay, so I'm looking at what would be easy to eliminate. I think it would be the x because I could just multiply the 6 by something to make it match the 24. So I'm going to multiply by +4 because I want the signs to be opposite, which they already are. So this becomes -24x plus 32y equals -48. I'm going to cross this out, and I'm going to rewrite that dark purple one underneath so I don't make mistakes when I'm adding the 2 together. So the x's eliminate. I have 2y equals -18, so y equals -9. Now again, you could plug in the y to these 2 equations, the equations up here, the equation I cross out here, or this one in dark purple. It literally does not matter. let's just plug it into this one. So I get 8 times -9 minus 6x equals -12. So -72 minus 6x equals -12. Add 72. So -6x equals 60. So x equals -10. Okay, so my final answer is -10, comma, -9. Okay, and finally, number 10, my variables are already matched up. I have to multiply both of them because I can't multiply 2 by something to match 7. So I'm going to multiply this top one by 7 because I know I can make them match at 14. So that becomes 14x plus 14y equals 28. I'm going to cross that out. Well, I need them to be opposite, so instead of multiplying by +2, I need to multiply everything by -2. So I get -14x minus 14y equals 0. When I add them together, my x's and y's eliminate, so 0 equals 28, which is not true. So my final answer is no solution. Okay, so that is the final method. Okay, refresher, remember we have, we could solve systems by graphing, which isn't the most efficient because sometimes you don't know exactly where your lines are intersecting. Then we have solving by substitution, where you solve for a variable and plug it into the other equation. And then we have this solving systems by elimination.